Most of you probably know the Collins KWM-380. This is the Rockwell Collins HF-380, which is a professional version of the KWM-380. The KWM was developed for the amateur market. This was the version that was intended for professional use. Embassies, the military used them, oil drill rigs, that kind of stuff. So the radio obviously is pretty similar to the KWM-380, but it has a couple of expansions compared to the KWM. And the expansions are not all visible. For instance, this radio is capable of transmitting anywhere between 1.6 and 30 megahertz. The KWM-380 only could transmit on the ham bands. And in order to be able to do that, the radio obviously needed different firmware, but it also needed an additional harmonic filter, which was an option for the KWM-380. In this particular one, it is installed, and I'll show you that later. The other expansions that you will find in this one is the presence of the audio processor, speech processor, in order to increase the average talk power. The KWM did not have that. The HF-380 had that standard. And the other thing that's installed in the HF-380 is the noise blanker. Works quite well, actually. That was noise blanker feature was installed standard in the HF-380. Last but not least, the HF-380 also has an ovenized reference oscillator, which is significantly more accurate and stable than the KWM-380. And that was, of course, a requirement for professional use, because this radio was also used a lot for data communication, and you need to be sure that you're at the proper frequency for that. Drift is not tolerated very well. And the FCC also prescribes that radios in professional parts, in commercial parts of the HF band, like marine radios is a good example, that they meet minimum accuracy and stability requirements, which was the case for the HF-380 here and not the case for the KWM-380. Now, lots of KWM-380s were upgraded by hams to HF-380 configuration by adding the options that you can always see on the serial number. This radio is a specific HF-380 from the factory, and it has the appropriate Collins part number, and the serial number also corresponds to that. So this is not an upgraded ham radio. This was the one and only HF-380 that was developed for the professional market. Now, I don't know if you saw my other video of the KWM-380. If you did, you probably know a lot about the controls already, because there is, of course, not much of a difference from a control standpoint. We'll go over it quickly. This is the meter selector, ALC for transmitter, the voltage, collector voltage for the PA, that only shows up when you transmit. Power forward, power reversed, again, only when you transmit. When you receive, this is basically the S meter. This is the carrier and the microphone power level. Carrier for CW and microphone for single sideband, of course. Microphone is one of those narrow jacks, often used in military and aviation equipment, but Collins also use it for this radio. They're a little bit hard to find, but they get the job done. This is the 1/4 inch phone jack. That's standard mono phone jack. Here is the mode selector. We have CW, lower sideband, upper sideband, and the radio is AM capable, only receive, not transmit. We have the AF and the RF gain. The radio has a variable IF feature, and that can be shifted all the way from upper sideband to lower sideband. So you got to make sure that that's set right, otherwise you won't be able to receive the correct sideband. And that is independent of the setting here. For instance, if you switch to lower sideband for the transmitter, the receiver won't follow that. Then you manually need to set that. A little bit weird. I don't know why Collins did that. I mean, the Drake TR7 has a similar concept, but there you can select either automatic sideband selection or manual. Here it's always manual for the receiver. The nice thing is, of course, that you can set the carrier point to the optimum level, and that actually works quite well. This radio allows for a whole bunch of optional filters. This is the 8 kilohertz AM filter. This was the standard 2.2 kilohertz single sideband filter. This is option 1, which is not installed. This is option 2, which is a 1.7 kilohertz crystal filter, and you use that for noisy conditions and DX work. You can really narrow up the sideband, the passband for the single sideband mode. Option 3 allowed for a third filter, which is not installed. So we have the 2.2 kilohertz filter and the 1.7 kilohertz filter installed in this one. The 8 kilohertz filter is basically the first IF filter, the roofing filter, if you want to call it that. This is an up-converting design. So at 8 kilohertz AM, you basically have the roofing filter as your selectivity. Let's go over the selectors here. The radio is capable of Vox. Vox is just transmitter, parallel to the push-to-talk switch. But Vox is basically automatic transmit when you start to talk without having to push the PTT button. And here are the settings for that. Vox gain, anti-gain, Vox delay, and you can also set CW delay here. So these are the not so often used controls that they have on the little window here. This is the VFO selector. We have a VFO A and B. A obviously is now set for the 20 meter band. B is also a register that you can fill whatever frequency you want, and then you can switch between the two. You can receive at A, transmit at B, and receive at B, transmit at A, so you can do shift situations where you can transmit in one register and receive on the other. Here we have the tuning speed. The radio is up to 10 kilohertz tuning accurate. And we can also go to 100 hertz steps, which I actually find the nicest way to quickly tune. We can go to 1 kilohertz steps. Oops, 1 kilohertz steps. And we can just lock, then nothing happens. And we can go to megahertz steps. Now, as you probably have noticed, this radio does not have a band switch. It's actually not a ham radio, it's a radio for 1.6 to 30 megahertz. And as such, you can pick any frequency you want. And you do that by changing the megahertz selector. And then going for the finer tuning, going to the kilohertz and even the hertz steps. Antenna that I have is tuned for 14 megahertz right now, but I'll show you some other bands later. So again, I like 100 hertz the best. but you can also do, if you like 10, you're just gonna crank this thing till you're blue in the face. But if you like that, you can do that. That was actually for the HF-380 and the KWM-380, of course, the real breakthrough in 1979 when this radio came out. The synthesizer is really a masterful design. This was the first ham radio on the market, and maybe even the first professional radio on the market, although I'm not sure, that was able to make 10 Hertz synthesized steps. All Japanese radios of the time, like the Yaesu FT1, you might remember that one, they don't make the 10 Hertz step synthesized. They do that by pulling crystals. This radio really has digitally synthesized 10 Hertz steps. And when this radio came out, that was an incredibly unique feature. What makes it even nicer is that this synthesizer is just incredibly smooth. You don't hear any jumps when you tune it. It almost feels like a VFO. That was another thing where Rockwell Collins was much better than the Japanese, because I remember the Japanese synthesized radios of the time. It's like jumpy, and this radio is just a smooth tuning experience. Apart from the perfect synthesizer, this radio also has just an incredibly nice receiver. I love listening to this radio. The AGC works just fantastic, and it doesn't give you that listening fatigue that you have on some of the early Japanese radios. This is just masterful design. Now, to be honest with you, you had to pay the price for that. I think this radio in the days was like $3,500. In today's money, that's, I think, over $20,000. So this might very well be the most expensive ham radio ever made. Of course, the KWM-380 was the ham radio. Uncle Sam ordered the HF-380, and that had a significantly higher price tag than the KWM. I don't know what this was costing the commercial market and the military, but I bet you that was close to $10,000 in the days, which is well, maybe close to $40,000 right now. So this was an incredible expensive radio. I think this might actually be the most expensive ham radio ever made. Obviously not the most expensive commercial radio, but for hams, I think there was no more expensive radio ever sold in the market. It was also Collins' last ham radio. Prices like that were not easily digested by hams, and they exited the ham market right after that. I think the last ones were made in '84, and after that it was over. But this one survived perfectly okay. It is in great shape. Let's see what I can do in terms of the transmitter. Quick look at the inside. This is the synthesizer card. This is also part of that. Here is the reference oscillator. It's ovenized for the HF-380. That is an oven. Here you see the noise blanker. That's optional and installed in this one. Here you see the control card, basically the microprocessor. It's a Motorola 8600 family processor. Here you see the IF and filter card. You can actually see one filter. There's two filters on this one, 2.3 megahertz and 1. Kilohertz and 1.7 kilohertz. Here, this is an extension of that. You can put additional filters in there. Here you see the speech processor. That was also optional and installed in this one. This is the transmitter filter, to basically the harmonic filter to make sure that the radio meets the FCC requirements. This is the standard, and this is optional part of the HF-380, so that the transmitter can operate on any frequency between 1.6 and 30 megahertz. Here is the power amplifier. You can see the board. It's in the shielded compartment. Here you see the power supply section, the pass transistors. Here is the input buffer filter capacitor. There is one on the output too. These are the current limiting resistors. This is the transformer. As you see, it's well built, cage construction, and still works very well after all those years. Here a quick view with the card cage closed. This is a cover for that. As you see, it takes many screws to close it, but it's really well protected this way. So looks very clean, this radio. And let's close it up again. This is, I don't know if I show that, power supply, pass transistors from RCA, and this is the power transformer. Let's put the case on and have a look at the back. Here we have the back of the radio, the so-called rear apron, and go over it quickly. This is the fuse, this is the antenna connector SO239, this is where the power goes. The radio runs off AC as well as DC. This is the Jones connector that mates with it. It can internally be strapped for any AC voltage you want, so any global voltage. Here we have the ID plate. You know, it's not that visible, maybe with a little bit of light, I don't know, but it's serial number 1248, and as you can see, it is actually a KWM-380. Sorry, an HF-380 from the start. You can see that from the Collins part number as well as the HF-380 name labeling. Alright, this is a ground lug. Obviously you can put audio in from the phone pads or whatever, audio out for a tape recorder. This is ALC for an amplifier, amplifier control. Antenna relay can be controlled externally, receiver in for external beverage antenna or something like that. Transmitter out, that's like for a transverter. This is a PTT, external PTT. This is the CW key, and this is the external speaker. This is for the remote keyboard. I forgot to demonstrate that to you. We have that for this radio, and I forgot to give you a quick demo, so we can do that. This is the keyboard that plugs in here, and then you can just direct entry, do a direct entry for the frequency. I will show you that in a minute because I forgot to show you that. Now here you can see the fan, the heatsink. It is a massive heatsink, and you really don't need external blower for that, but weird enough, the HF-380 did have a blower kit as an option. I think that was probably for continuous duty cycle modes like RTTY, but for normal ham mode you are not going to need a blower at all with the size of this heatsink. So let's quickly show you that keyboard that I forgot to do. For the transmitter, we obviously are going to need a microphone. This is the microphone that came with the radio. It is a strange bird. I've never seen anything like it before. It looks like it's Collins. It has one of those labels. Most of the lettering came off, but all Collins genuine accessories always came with those white labels. It works actually very well. It does seem to be missing a cap here, although it's not really impacting the microphone. But it lays in your hand very well, and as you will find out, it does a good job. So, strange microphone, but it did come with the radio, and I think it's original. For the transmitter, we'll switch the radio to the dummy load to not bother anybody. By the way, that also shows you the sensitivity of the radio. This is the S meter with the external antenna. And now I'm on the dummy load. As you see, it falls back right away. I have an incredibly high noise level at this location, but it also shows you that the radio sensitivity is excellent. Let's test the transmitter. Okay, to test the transmitter, I'll use my Yaesu FT817 as the monitor receiver. We're at 14.170 for both radios. 1, 2, 3, 4, 5 testing. Radio is a little bit more than 100 watts here. 1, 2, 3, 4, 5. Modulation is excellent. I can turn on the noise blanker. Sorry, this processor. 1, 2, 3, 4, 5. This is with processor. 1, 2, 3, 4, 5. The average power is much higher now. 1, 2, 3, 4, 5. The nice thing about the processor is that you can also then use the mic gain as a power control. I'll show you that. One, two, three, four, five. 1, 2, 3, 4, 5. As you can see, the power is now limited. One, 2, 3, 4, 5. The speech processor prevents the peaks to go over, in this case, about 5 watts. 1, 2, 3, 4, 5. So with the speech processor on, you can also use that as a power control during transmit. 1, 2, 3, 4, 5. 1, 2, 3. Modulation is actually very good. Let's try lower sideband. All right, lower sideband. 1, 2, 3, 4, 5, 6, 7. This is lower sideband. Lower sideband. 1, 2, 3, 4, 5. Sounds excellent. 1, 2, 3, 4, 5. Lower sideband. Now remember, if you want to receive lower sideband as well, you'll have to move the. I'll show you what I mean with that. Now I'm transmitting with the Yaesu, and nothing is coming through until I. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You see, I have to retune the IF shift to lower sideband, otherwise the receiver won't follow the mode switch. That's one thing you always have to be aware of. That is a little bit strange of this radio. So modulation works very well. Frequency is so accurate. I actually have the high stability frequency standard in this radio, and as you can see, as you can hear, they are practically at the same frequency. Let's see what kind of power levels we get at other bands. For the other bands, we will test the power, and we'll switch to the dummy load. And this is also a good opportunity to show you the keypad. To get there quickly, we go to 1.9. Enter. I did that wrong. 1.9. Enter. We are now at the 160 meter band. And we get about 100 watts. 1, 2, 3, 4, 5. We get about 100 watts at 1.9 megahertz. Let's go to the 80 meter band. 3.8. Enter. That's where we are now. Get about 95 watts there. 1, 2, 3, 4, 5. 80 meter band. 1, 2, 3, 4, 5. Works quite well. .95 watts actually. A little bit less than the other band. Let's try the 60 meter band. What is that? 5.4. I don't know. Let's try that again. 5.402. I don't know exactly, but we're there now. About the same power as on the 80 meters. 5.402 60 meter band. As I told you, this radio has transmit capability anywhere from 1.6 to 30 megahertz, so obviously 60 meter is no problem either. Let's do the 40 meter band. 7.2. That's where we're now, thanks to the keypad. Yourself about 1, 2, 3, about 120 watts there. 1, 2, 3, 4, 5, 40 meter band. That works as well. 10 megahertz band, that is the 30 meter band. That would be 10.1. 10.1. Alright, that's where we are now. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That seems to work too. 10.1 megahertz. 17 meter band. That would be 18.1. Enter. About 120 watts. 1, 2, 3, 4, 5. Modulation sounds good. Gets boring quickly. 15 meter band, that would be 21.3. That's where we are now. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's the 15 meter band, 21.3 megahertz. 12 meter band, that would be a 24.9, and that's where we are now. 115 watts. 1, 2, 3, 4, 5. 12 meter bands, 24.9. That works as well. 11 meter band, that would be 27.385 for channel 38. 1, 2, 3. 1, 2, 3, that works as well. 11 meter band. I told you the radio can transmit anywhere, so I had to show you that. 28.3, I already said it there. Speed up things a bit. 110 watts, 1, 2, 3. 28.3. And that seems to work as well. Now, I told you earlier that the Collins HF-380 can transmit anywhere. And to prove that, we'll just pick a arbitrary frequency. Let's pick 16.8. And don't panic now, we're on the dummy load. So don't give me a thumbs down in the comments section. But anyway, we're at 16.8 at the dummy load, upper sideband. And as you see, we transmit quite well there. 1, 2, 3 at a random frequency in the shortwave band. And that works as well. Alright, that was basically it. The Rockwell Collins HF-380, an original HF-380, not a modified KWM-380. This is the real thing, and works perfect. Thank you for watching this video.
I think the 7851's got even a better front end on it. Compliments there. Nice audio coming out of that. Be interesting to know what microphone you're using and if you have any audio proof of it, just using the radio on that transceiver, Joel. Cool, actually today, temperature maximum about 14 degrees only.
Transmitiendo. ¿Cómo estás, amigo? Buenas tardes. Espero no haber interrumpido alguna plática ya que estoy.
I don't think that guy ever recovered, but a real nice guy.
You're 26 again.
Number is calling CQ and standing by for a call.
Attention, number 3 Echo Oscar November. This is Papa Alpha 9. Lima Echo X-ray. Good evening.
Papa Alpha 9 Lima Echo X-ray, I believe. Papa Alpha 9 Lima Echo X-ray. I'm getting a little Q on Mary on the frequency, but you're 5 and 9 here. Good signal coming into the state of Maryland. Mike Delta, the name is Steve. Sierra Tango Echo Victor Echo. Steve is my name. QSL?
Yeah, Roger Steve, copy that 100% in the state of Maryland. November 3 Echo Oscar November. This is Papa Alpha 9 Lima Echo X-ray. Well, my name is the same as my subject. Lex Lima Echo X-ray, that's my name. Mike, back to you, and I'm, you know from the call, I'm from the Netherlands here, and your signal here, when you come back to me, I have a look at the signal meter, what's going on. Mike, back to you, from Papa Alpha 9 Lima Echo X-ray.
Okay, Lex, I thought that probably was your name.
Very good. Phone with your pilot there. November 5 Fox Uniform November. Clear with ON8KW. Thanks.
Yeah, you were doubling with someone else, but can you give me your call? Your name again? November 5 Fox United November only, please.
QSL, the name is Rob. Romeo.